In today's lesson, we're going to look at partial fraction decomposition. And this is where we can take a rational expression and decompose it into multiple rational expressions added together. This is a helpful tool or skill in calculus when you get to that. But for now, we're really going to be focused on just breaking down these rational expressions into multiple. And so what that looks like is creating a set of rational expressions added together where the denominators are all unique. And so they're called distinct linear factors. So each one of those denominators is going to be linear, and the denominator is different on each one. Okay, so if I look at this first example, what we want to do is separate this out into an expression. So we want to take this x minus 8 over x times x plus 2 and somehow get a fraction where it is some numerator over x plus some numerator over x plus 2. And so the first thing you're going to end up doing when you work through these things is factoring the denominator. All right, so let me just write that out here. Factor the denominator. And set up your decomposition. So this is what I mean by setting it up. We have some value over x, some value over x plus 2. And if we had more factors in the denominator, we would have more fractions to keep going on. Then we can multiply by that least common denominator. So what that would look like here, if I multiply by the least common denominator, which is just x times x plus 2, if I multiplied it through x times x plus 2, let's just write it out, and then we'll get the long version of this. We had x minus 8 over x times x plus 2. We are multiplying x times x plus 2 equals a times x plus 2, and it's already over x, plus b times x plus 2, and it's already over x plus 2. So the reason we multiply by that least common denominator is because what we'll see is that the denominators disappear, they reduce out, so x and x plus 2. Now I have just an equation that's x minus 8 equals a times x plus 2 plus b times x. There's no longer a fraction here, but we're trying to figure out what are the a value, a numerator, and the b numerator. So the third thing you're going to end up doing is let x equal your critical values. And so if I look at these and we try to figure out what is a critical value for this, really you're thinking about the zeros of this function. So one of them I'm going to pick is when x is equal to -2. And so let's see what that looks like algebraically. So let x equals -2. What happens is we get an equation that would say -2 minus 8 equals a times -2 plus 2 plus b times -2. So -2 minus 8 is just -10 equals a times 0 is just going to be 0, so that's going to disappear. Plus b times -2 is -2b. So our equation is just -10 equals -2b, and we would divide by -2. So b is equal to 5. By letting x be a critical value there, we eliminated one of those variables that we were trying to solve for, and we solved for b. Now let's let x equal the other critical value. So if I think about what would make this 0, it's just 0. So in that case, I have 0 minus 8 equals a times 0 plus 2 plus b times 0. Now we work that out algebraically to get -8 equals 2a plus 0. So a is now -4. If the question just says find the a and the b for the denominators, or for the numerators over these specific denominators, you could put those in there. But really it's asking you to write this as a partial fraction. So when I write this out, I want to make sure I'm putting the correct numerator over the right denominator. So I had a was -4, so -4 is going to go over the x because I set it up that way. So I'd rewrite this as -4 over x plus, and then we go to 5 over x plus 2. All right, now we chose which order we wanted to write them in as far as the denominators. So this would be a correct answer for writing out your partial fractions. You may also see this written as 5 over x plus 2 plus -4 over x. Well, that's the exact same thing. It's just written in the other direction. So both of those are equivalent. Either one is correct. I know that on some of the questions that I have in Blackboard, you'll be specifically asked to write the numerator or the fraction with the smallest numerator first. So in that case, it'll be -4 is smaller than 5. So I'd put this one first and then that fraction, but that's specifically just because I needed to code it correctly for the computer to grade that question. All right, so for number 2, I have 7x minus 1 over these, and it's already factored, so I can set up my equation. So I'd have 7x minus 1 over x plus 5, x minus 3, equal to a over some denominator plus b over another denominator. So it doesn't matter which order you put them in. I can have x plus 5 first, x minus 3 next, that's fine. But we want to take that and multiply by the least common denominator. In our case, I would multiply by x plus 5 times x minus 3. And I'm not going to write it out every single time, but what happens when you multiply it through is this denominator is going to cancel out, or sorry, that x plus 5, x minus 3 cancels out with that denominator to give me just 7x minus 1 equal to a times the x plus 5s would cancel out and x minus 3 would be left, plus b times, we multiply it here, the x minus 3 would cancel out and x plus 5 would be left. Now we can let x be our critical value. So that was the last thing there. Really the last thing would be write the partial fractions. Okay, so if x is, let's say 3, then that would say 7 times 3 minus 1 equals a times 3 minus 3 plus b times 3 plus 5. That's 20, 21 minus 1 is 20. 3 minus 3 is 0, so a times 0 is just 0. And b times 8 makes that 8b. When we're solving this out, I'm going to divide by 8, but I get 20 divided by 8. And we can use the calculator for that, but it's not going to come out evenly. And we don't want to write a decimal. You always want to turn this back into a fraction, even if it's improper. So for these, it's going to be 5/2. That's our b value. And we then solve for a, so let x equal -5 in this case. And it would say 7 times -5 minus 1 equals a times -5 minus 3 plus b times -5 plus 5. So that would be -35 minus 1 is -36. There's -8a. And then plus 0. So I divide by -8. And again, this is going to come out improper. So 9/2. I can write my fractions, but we're not going to be able to leave a fraction on top of a fraction. So let me show you how we would end up writing it. I have 9/2 over x plus 5 plus 5/2 over x minus 3. And then we have to simplify this further. All right. So algebraically, what's going to happen is that 2 is going to end up in the denominator. So it's going to say 9 over 2 times x plus 5 plus 5 over 2 times x minus 3. But let's go through, how did that actually happen? We saw this when we were working with rationals a while ago. But if I had 9/2 divided by x plus 5, we could rewrite that as 9/2 times 1 over x plus 5. And then that would be 9 over 2 times x plus 5. So that's all that's happening right there, but when you see the fraction on top of a fraction, just know that you cannot leave it that way. You need to simplify it down into this expression. All right, so let's try 2 more. You can pause the video and try them on your own, or you can do them with me. Okay, so for this one, I need to factor it first. This would have factored into x minus 5 times x plus 4. So that gives us an idea of what these denominators are going to be, but I have x plus 2 over x minus 5 times x plus 4. It's equal to, and we write our partial fraction stuff. So x over x minus 5 plus b over x plus 4. If I take that and multiply by that common denominator, it would have been x minus 5 times x plus 4. So this would leave us with just x plus 2 equals a times x plus 4 plus b times x minus 5. And let's let x equal a -4 first. Then we can do it again where we let x equals +5. So if x is -4, that'd be -4 plus 2 equals a times -4 plus 4 plus b times -4 minus 5. So -4 plus 2 is just -2 equal. That's our 0, so 0 times a is just 0. And then b times negative 9 is negative 9b. I divide by negative 9, and I get a positive 2/9. So we'd have a fraction again. And then we do it again for when x is 5. So that'd be 5 plus 2 equals a times 5 plus 4 plus b times 5 minus 5. So 7 equals 9a plus 0. Divide by 9, I get 7/9. So we have two fractions again. A over x minus 5 would make this 7/9 over x minus 5 plus 2/9 over x plus 4. But we can't leave it that way. We have to take that and simplify further. All right, so in our case, this would say 7 over 9 times x minus 5 plus 2 over 9 times x plus 4. And the last one. It's already factored for us, so that makes it a little bit easier to set up. I've got 2x plus 1 over x plus 2 times x minus 3 equals a over x plus 2 plus b over x minus 3. If I multiply by that common denominator, it would be x plus 2 times x minus 3. Leaves us with just 2x plus 1 equal to a times x minus 3 plus b times x plus 2. And now we have our critical value part. So let x equal a positive 3, and the second one's going to be x equal to a negative 2. So when I plug this in, 3 here, 2 times 3 is 6, 6 plus 1 is 7. 3 minus 3 is 0, so 0 times a. But here we'd have 3 plus 2 is 5, 5 times b. So b is equal to 7/5. And then we do it again here with x equals negative 2. So 2 times negative 2 is negative 4 plus 1 is negative 3. Negative 2 minus 3 is negative 5a. And then negative 2 plus 2 is 0, so 0b. And if I work out this, I divide by negative 5, so I'd end up with a positive 3/5. Those are our two numerators. And if I set this up, a is 3/5 over x plus 2 plus 7/5 over x minus 3. We can't leave it that way. We keep going and simplify that so that we have 3 over 5 times x plus 2 plus 7 over 5 times x minus 3. All right. And so the last thing I would do is try to practice some of these that are in the lab manual as well.